Hello everyone, today we are going to be focusing on multiplying in scientific notation without the need to rewrite. That means when you multiply, it is already going to be in scientific notation. Before we start though, I want to just remind you how to write numbers in standard form and scientific notation. So pause for a moment and see if you can do these problems, and then turn it back on and check your answers. Okay, so for this first one, what this tells us is that we are multiplying by a power of 10. And it is going to be, when we are finished changing to standard form, it is going to be a large number. So we know that we have to move the decimal 5 places, and it's going to end up being a large number. So 1, 2, 3, 4, 5. And we put zeros in to have placeholders, and then we rewrite. So it's easy to see, and then we add our commas. And again, to put commas in, you start at the end, and you count 3 places, and you put a comma. And there you go. Notice that the final answer doesn't have a decimal in it. You could put one right here and put 0.0, but you don't have to. If you have a small exponent, that means it is going to be a small number. So negative exponent, small number. And remember why. This negative exponent tells us that really what we're doing is multiplying excuse me, by 1 over 10 to the 5th, or dividing by 10 to the 5th. So it's going to be a small number. So you're going to move the decimal over 5 places this way. 2, 3, 4, 5. And add in your zeros. So it'll be 0.000083. A common misconception is that this number tells us the number of zeros, but it doesn't. It tells us how many places we're moving the decimal. All right, next one. Express the number in scientific notation. Remember, this A has to be at least 1, but less than 10. So when you are moving the decimal, you need to stop after you get to a place where there's just one non-zero number before it. So this would be 1.23 times 10 to the, we moved it 1, 2, 3, 4, 5, 6 places, and remember we had a very small number, so the exponent is going to be negative. Here we're going to move it this way, 2, 3, 4, 5, 6, 7, 1.23 times 10, and it was a large number, so your exponent is going to be positive. And this is what we are going to be learning today. So to multiply numbers in scientific notation, you're going to multiply the decimal numbers and add the exponents. Okay, so I like to start by regrouping. So I regroup. So what I did was I took my decimal numbers, or the ones that are not the power of 10, and wrote them next to each other. This is the associative property and commutative property. The associative property tells us that with multiplication, they can associate with other numbers. And the commutative property tells us that we can exchange places. So I just rewrote it so the 3 and the 2 were next to each other, and the 10 to the 4th times 10 to the 5th were next to each other. So 3 times 2 is easy. That's 6 times, and this is where your exponent rules come in. You know this. When you're multiplying powers with the same base, you add the exponents. So the base stays the same, and you add the exponents. So 3 times 10 to the 4th times 2 times 10 to the 5th comes out to be, very simply, 6 times 10 to the 9th. It is much easier that way than putting it into standard form and then multiplying. So again, computations with scientific notation. What you're going to do is regroup, simplify, make sure it's in scientific notation. So I'm going to regroup, putting my numbers next to each other, and putting my powers of 10 next to each other, to the fourth. Then I'm going to simplify 1.5 times 2. That's like $1.50 times 2. You end up with 3 times 10 to the, when you're multiplying powers with the same base, you add the exponents. So I get 3 times 10 to the 7th. Next one, it is in standard form. I think it is so much easier to multiply when it is in scientific notation. So I'm going to change these to scientific notation first. So I had to move the decimal 1, 2, 3, 4, 5, 6 places, and 1, 2, 3, 4 places. Then I'm going to regroup 5 times 1 times 10 to the 6th times 10 to the 4th, and then simplify. 5 times 1 is 5 times 10 to the, when I'm multiplying powers with the same base, I add the exponents, so 10 to the 10th. So extremely easy when it's in scientific notation. And I'm going to hold off on this example for right now. Let's go practice some other ones. All right, so remember we regroup, so we're going to put our numbers next to each other and our powers of 10 next to each other. Then you're going to simplify. 4 times 2 is 8 times 10 to the, when you're multiplying the powers, you add the exponents. So 3 plus 8 is 11. And then the last step is making sure it's in scientific notation. I've already told you that for these, I tried to make them all in scientific notation. What makes it in scientific notation is this number right here. Remember, it has to be less than 10 but greater than 1, or 1 or greater. And 8 is. It falls in between there. So this is in scientific notation. This is your answer. So we regroup. 3 times 3 times 10 to the negative 8th times 10 squared. And then we simplify. 3 times 3 is 9 times 10 to the, when we multiply powers with the same base, we add the exponent. So I'm going to just write this up here. Common mistake is forgetting integer rules. Negative 8 plus 2. Unlike signs, you subtract, and there's more negatives, so it's going to be negative 6. So we regroup. We put our decimals next to each other and our powers of 10 next to each other. We simplify. And when we're multiplying powers with the same base, we add. So I'm going to write that up here so I can see negative 9 plus 2. Unlike signs, we subtract, and there's more negatives. And then the last step I forgot to check, is it in scientific notation? Back to the last example, this one is between 1 and 10, so yes, it's in scientific notation. 6 is between 1 and 10, so it's in scientific notation. Now I'd like you to pause the video and try a couple of these. See if you can do the regrouping, multiply, and then add, and then restart to check your work. Okay, so here we're going to regroup. Did you do that? Then you multiply. If you can't do this in your head, you can come off to the side. I also don't care for this one if you use just a regular calculator to do the multiplication part. Times 10 to the, and when you're multiplying powers with the same base, you add the exponents. Like signs, we add, and they're both negative, so it's going to be negative 11. The decimal is between 1 and 10, so that's in scientific notation. We regroup, putting our decimals next to each other and our powers of 10 next to each other. We simplify, and again, if you can't do that, do it off to the side. 1.5 times 6, so 6 times 5 is 30. Carry the 3. 6 times 1 is 6 plus 3 is 9. So that's 9.0 times. And when we multiply powers with the same base, we add. So I'm going to do this over here so I can see. Unlike signs, we subtract. So 7 minus 5 is 2, and there's more negatives, so it's going to be negative. This is between 1 and 10, so it's in scientific notation. And the last example for right now, we regroup. So I have my decimal part next to each other. Oops, 6. We simplify. I'm going to do this off to the side. 2 times 2 is 4. 2 times 4 is 8. There's one decimal, so I'm going to put the decimal there. Times 10 to the, and when we are multiplying powers with the same base, we add the exponents. So unlike signs, we subtract, and there's more negatives, so it's going to be negative 3. I'm going to look at my decimal. It is between 1 and 10, so this is in scientific notation. So that is my answer. We out.